So let's look at the next warning in our eplusout.err file. It says, warning, check convexivity, zone, thermal zone 1, and it tells you what surface is applicable, is non-convex. What is convexivity, and what is convex, and what is non-convex? We will copy this text and search for it in the EnergyPlus Input-Output Reference Manual. And it takes you to this bit of information about, and it describes convexivity, and it tells you that convexivity is only applicable, or rather it's only seriously affects your model if you are running full interior and exterior, or full interior and exterior with reflections. So what do these selections mean in OpenStudio? If we go to the Simulation Settings tab, and we go to Simulation Control, and we go to Solar Distribution, it gives you an option for how EnergyPlus will simulate the model. And right now, we only have full exterior selected, so it will be only modeling the energy effects of the sun as it contacts exterior surfaces. It will not be taking into account sun reflections going through windows and bouncing off floors and walls. If you want to model full solar effects that go through windows and bounce off the inside of the spaces, you need to model full interior and exterior, or full interior and exterior with reflections. But if you are modeling just full exterior, like we are, you really don't have to worry about these non-convexivity issues. Let's go back and take a look at what exactly convexivity is. So, in a nutshell, this shows convex zones and non-convex zones. And by definition, a convex zone is where a light ray will only pass through two surfaces as it enters and exits the zone. Whereas a non-convex zone is where a light ray would pass through more than two surfaces. So you can see, for example, if this light ray went through this wall right here, and it might pass out through this wall right here, it really only passes through two surfaces. Whereas this light ray might pass through this window right here, and it might go out through this wall, and it might go in through this window, and then it might also pass out through this wall. So right here you see how it's non-convex because it's actually transiting 1, 2, 3, 4 surfaces, whereas a convex zone would only pass through two surfaces. So that is the definition of a convex thermal zone and non-convex thermal zone. And if you take a look at our building right here, you can see that there's a lot of spaces that we have here, but all of these spaces are actually grouped into only one thermal zone. And that one thermal zone, all of these spaces get combined into one big thermal zone, and they get passed to EnergyPlus as a single thermal zone. And so you can see that our building is actually quite non-convex. You know, if you drew a line passing from one side of the zone to the other, you can see that it actually passes through multiple surfaces. So that's what this warning is telling us. If you do have zones that are non-convex, you're going to get this warning. Now there are also non-convex surfaces as well, but and I will talk about those in just a minute. But as I said, if you are only modeling full exterior, you don't have to worry about these non-convexivity errors. So let's now discuss what convex and non-convex surfaces are. So this is saying that we have a surface number 100, which is non-convex. First of all, we can search for the surface 100 in our OSM file. And you can see that this surface 100 is composed of 1, 2, 3, 4, 5 vertices. And we can search for the surface 400 in SketchUp. Go to Surfaces and Surface 100. And usually you can see it highlighted here. This is surface 100. You can turn on visibility X-ray mode to see better sometimes. Otherwise, what you can do is you can go to Edit, Face, Select, All Connected. And that gives you a better idea of what it's connected to. So it's connected to this zone. So we're going to double click into this zone. And again, we will look at surface 100, which happens to be this roof ceiling right here. And you can see that it has 1, 2, 3, 4, 5 vertices. So this could be a problem if all of the vertices are not quite on the same plane. According to this, they all have the same z coordinate. That doesn't mean that they might not quite be on the same plane. And if they're not on the same plane, if one of these vertices is not on the same plane, you end up with a surface that is not completely flat. And this confuses EnergyPlus. So if you want to get rid of this warning, it's not a serious error, and it won't really affect your energy model unless you have a very serious non-convex surface. If you want to get rid of this error, you can simply connect some of these vertices, and preferably you would connect them into triangles like this. That way, you don't have a surface that's potentially in the shape of a convex, or in the shape of a U. And that's how you get rid of that error. So what you could do is you could go through every single one of these. Surface 113, surface 159, surface 175, surface 172. And you could go to all of these surfaces and just connect all the vertices. So we can go to surface 113. And it's right here. Okay, so we've gone through those surfaces that were in the error file, and you can see that we added the all of the triangles to those surfaces. Let's go ahead and reload the model. So we will save the model in SketchUp, and we will reload the model in OpenStudio. And we'll go ahead and run the simulation again. And the simulation was successful. Let's go back to our error file, reload it, and you can see that those errors got removed. Let's look at the next error, get vertices. Distance between two vertices is less than 0.01, possibly coincident. And it shows the surface number, what it's associated, and the thermal zone it's associated with. And it says that there's vertex 5 and vertex 4, and you can see that the difference between these is less than 0.1. And then it says it's going to drop vertex 5. So let's go ahead and take a look at this surface 200. Again, go to the OpenStudio inspector, go to surfaces, and we're going to browse for surface 200. Surface here. Looks like it's this one. It's a floor. So we will edit this and we'll take a look at this, and you can see that it does have multiple vertices. 2, 3, 4, 5 vertices. And if we zoom in on this, see that it's these two vertices are very close to each other. And this could have happened when we were tracing the floor plans, and our polygon ended up with this extra fragment here. So that's what this error is saying. It's saying that this vertex is, these two vertices are very close to each other. And because they're close to each other, because they're so close to each other, EnergyPlus is saying, well, I'm just going to drop this vertex 5. And I would suspect that it's probably doing the same thing for surface 209 on the top. As you can see, surface 209 also has that issue. And if we look in their error file, yes, in fact, it does say that. It's saying that surface 209 has the same problem. So because those vertices are so close to each other, EnergyPlus is saying, well, we're just going to get rid of these vertices. And is going to continue on with the simulation. So clearly, this is not a very significant surface area. This is not a significant error. It's not going to destroy the model. So EnergyPlus continues to simulate. And in fact, it's not going to have a big impact on your energy model. But if you did want to resolve that error, if you want to make sure that these are planar, you can draw a line between these two vertices, and you can see that this axis is sort of swept inward. So in order to fix that, you can just simply move this. So we will select this line and click the Move button and move it that way. And that solves the problem. It solves the problem for both the floor and the roof. How you solve that problem. And again, it's not a major error, but if you want to get rid of those errors, that's how you solve the problem. And now that we've solved all those, let's go back and reload and rerun the simulation. And it was successful. And if we go back and look at the error output file, you can see that all of those non-convex errors have been resolved. That is enough for today. We will continue these series of videos troubleshooting errors in future episodes. Thank you. Please like and subscribe.